I want you to look at this geometry problem with a beautiful diagram. We got a quarter circle and a semicircle, each having an area of pi square units inscribed inside a square. Do you think you can solve for the area of the square? If you do, go ahead and hit the pause button and try it on your own. First thing that we will do, of course, is to solve for the radius of the quarter circle and semicircle. Let R1 be the radius of the quarter circle, and let R2 be the radius of the semicircle. The area of the quarter circle is equal to 1/4 times pi times R1 squared. The area of the quarter circle is pi, so the equation becomes R1 squared equals 4. Take the root of both sides to get R1 equals 2. Next, the area of the semicircle is equal to 1/2 times pi times R2 squared. The area of the semicircle is pi. Simplified just like we did above, we should get R2 equals square root of 2. The crucial part of our solution is properly recognizing the location of the tangency point of the quarter circle and the semicircle. Well, the only way we can fit them perfectly inside this square is if their tangency point is also the center of the square. If that point isn't at the center, then you have a rectangle, not a square. Now let's proceed to the next step. From the tangency point, draw the horizontal radius of the semicircle to the tangency point with the square. Draw the vertical radius as well. The radius of the semicircle is square root of 2. Radius to the tangent line is always perpendicular to the tangent line, so this angles must be 90 degrees. Squares have right angle corners, which makes this angle also another right angle. We have formed a smaller square with side lengths of square root of 2. From the tangency point, draw the diagonal of the small square. Recall that the length of the diagonal of any square is equal to its side lengths multiplied by square root of 2. So the diagonal is square root of 2 times square root of 2, which simplifies to 2. The radius of the quarter circle is 2 units. Therefore, the diagonal of the entire square is 2 plus 2, or 4 units long. Assume the side length of the square is x units. Recall again that the diagonal of a square is equal to its side length times square root of 2. Therefore, we have 4 is equal to x times square root of 2. Divide both sides by square root of 2. Rationalize the denominator by multiplying both numerator and denominator by square root of 2. This becomes 4 square root of 2 over 2. 4 divided by 2 is 2. So the measure of x is 2 square root of 2. Finally, the area of a square is side squared. So the area is 2 square root of 2, all squared. 2 squared is 4, while square root of 2 all squared is 2. And 4 times 2 is equal to 8. The area of the entire square is 8 square units. Thanks for watching.